Hello and welcome to Digital Storytelling. Today we'll be talking about Kilo, the mermaid. Yes, the kind of mermaid where they're half human, half fish. He is a blue angel, a type of fish that floats on the surface. It's extremely tiny, probably about less than an inch. But he's red, which we're going to find out is the result of transcription, translation, and a mutation in proteins. Now, transcription starts with initiation, elongation, and termination. Initiation begins with a promoter. It begins the transcription. The promoter is before the DNA sequence, and the promoter tells RNA polymerase where to latch on. Then elongation begins, which RNA polymerase will move along the DNA strand, creating mRNA strand with codons, which is 3 mRNA bases in a row. Then there's termination, where the terminator, which is at the end of the DNA strand, will stop transcription. This makes RNA polymerase detach with the mRNA strand. Now, mRNA at this stage is a pre-mRNA, which means it has exons and introns in a pattern. It needs to be fixed and all introns need to be removed so that only exons remain. But it's still not done after that. Now that we have all exons on the strand, we need to add a cap and a poly-A tail. The tail's length depends on how many times mRNA needs to be transcribed. It'll keep it safe before other enzymes eat it. Now we have a ribosome, which is an ugly blob thing. It has a P site and an S site. It calls for the right tRNA to come to the mRNA strand. It regulates the tRNA as well. Now we will begin translation, which has 3 steps: initiation, elongation, and termination. Initiation starts with the start codon, which tells the ribosome where to attach. Elongation is when the ribosome moves along the codons and the mRNA attracts tRNA with anticodons. And now during this process, amino acids are traded back and forth between tRNA molecules so that an amino acid chain is formed and elongates. tRNA is made up of anticodons, which are complementary to codons. After this, we will begin termination. Termination begins with a stop codon, which is either one of 3 codons, UAA, UAG, or UGA. And this tells the ribosome that it needs to stop attracting tRNA and begin to detach so that the amino acid chain is left. Now we are left with an amino acid chain which will code for proteins. But we still need to learn about mutations. Mutations begin with 2 mRNA strands, one of which is normal, the other one, which is mutated, which may have only one base that can change the whole protein. That is called a mutation type substitution, where only one base is changed. There are 2 types of mutations: silent mutations or frame shifts. Silent mutations are usually substitutions, and there's barely any change. They don't cause any harm. Frame shifts are very, very deadly and harmful mutations that are usually deletion or insertion, and they are very, very bad. Point mutations only affect one gene, and this would explain that our friend Kilo, why he is red, not blue, because he has a gene that is mutated using the form of substitution that has changed his coloration. And for right now, we're done. See you next time. Well, I hope you enjoyed the video. Here's a full picture of me drawing a serious picture of Kilo because I just sketched him out with marker before. Please enjoy this for the rest of the video, and I hope you understood anything I was saying. Yeah.